Hello and welcome to another exciting episode of the Engineering Career Coach podcast, where I'll be talking with Josh Valman. He's a CEO of RPDK. He's an Innovation Board Advisor to the Royal Academy of Engineering, an Investment Committee Board member at the British Design Fund. In today's episode, we're going to discuss the crucial transition from formal education to the real-world application of engineering skills, the gaps that exist between academia and industry practices, and how aspiring engineers and current engineers can bridge these gaps to build successful, fulfilling careers. I'm your host, Jeff Perry. I'm a leadership and career expert and author of The Intentional Engineer. You can find more information on my work at jeff-perry.com. And this is the Engineering Career Coach podcast brought to you by EMI, the first podcast dedicated to helping engineers and technical professionals with both their personal and professional development. Now it's time to jump into the main segment of this episode. I have the pleasure to have with me today Josh Valman. Josh, welcome to the Engineering Career Coach podcast.
Hey, Jeff. Thanks for having me.
Yeah, so Josh, I'm excited to dig in here and get to know you a little bit better. So we were talking just a little bit about you and some of the things you've done in the past, but share with our listeners a little bit about your career journey. How did you transition? How did you get into engineering from where you came from? And what are some of the things you've been able to work on over the years?
Yeah, for sure. I mean, I've had a bloody weird engineering career. I have no formal education. I'm not sure I can even claim I'm an engineer, right? I started when I was about 10 with Robot Wars. So I guess BattleBots in the US. So when I was a kid, this stuff was on TV. And like, for anyone that hasn't seen that, which was just mad, right? It was as a 10-year-old, watching people build robots to try and attack each other on TV was about as exciting as the world gets. So I was obsessed with this thing. I was convinced that this was going to be kids, right? This is surely something that only kids do. This cannot be an adult thing. Turns out it's huge amounts of corporate sponsorship. Everybody's got 6 degrees and a PhD, and I was 10, right? I built stuff with some Lego and some sellotape, and I turned up and massively outclassed by some of these guys. And they didn't send me away, so I spent the next few years really focused on learning how to do what they would do. Quite conveniently placed it, but when internet and Google were becoming something, which I'm sure some of the older listeners won't even remember that world, but there used to be a world before the internet and you couldn't Google something. But I was very lucky that I was learning this stuff when you could go, how do you make this? How do screw threads work? How does this work? And just question by question, learn how to design this stuff, learn how to do the CAD, and very quickly got to the point where I just couldn't make this stuff at home. We had a bench vise and a drill, but couldn't make most of this stuff. So I started going to factories in the UK, and I take my parents, I had a paper round, so I had £13 a week or something in coins, and I'd turn up with some drawings that I'd made and some aluminium I'd bought on eBay, and I'd say, right, can you machine this part? And occasionally I'd find somebody that helped me out and go, I don't understand what's happening here, but I'll make this part for you, that's fine, it's £12, and off you go. But most people would have this joke and say, you should go to China, go and spend your pocket money in China. You could actually afford, you buy a whole factory. And this was back long before China was very accessible for manufacturing. So no local Chinese factory had a website. So you could Google Chinese factory, and the only thing you'd find was somebody from the UK or the US or maybe Europe who'd gone and set up a facility out in China, but, were operating in a Western way. So it was almost too easy to go and find Chinese manufacturers and speak to you in English. You could trade on PayPal, and I was making all sorts of stuff. I had 5-axis CNC machines when I was 13 years old. Like, you could just make anything you could draw in, Google SketchUp back then, and you could machine it. And so I made some pretty crazy things just in robotics, just pushing how far I could design something, until eventually got out of control. I started helping companies, helping them work out how to use factories in China, just consulting, but nobody really asked how old I was. So I was about 17, I think, when I got sacked, because I was doing enormous sums of money in helping people move things around the world in different factories, and no one had really asked how old their supply chain consultant was. So I came to an end pretty quickly when they worked it out, and I started RPD 15 years ago now, which we sold it for a larger group last year. So through that time, we were developing shampoo bottles through to IoT and wearable devices, tablets, phones, lots of medical equipment, really incredible stuff that was saving lives, and incredible fertility treatment devices and all sorts of stuff. And it was great fun, but the focus has always been on how you take an idea and actually make it and manufacture it as quick and efficient as possible. And I guess that's always been the way since Robot Wars.
Yeah. So it's interesting, obviously a non-traditional path to get into robotics and engineering and manufacturing and things like this. Certainly a far cry, because you went through a lot of this mostly self-educated on most of these topics through trial and error, trying things out. You had a problem you wanted to solve, you figured it out, and then others were asking you to help them solve their own problems, right? Along these things. And so what's the disconnect and the gap that you notice in this space between the way you were able to figure out and learn some of these things, what the real world is really demanding of engineers and innovation, and what schools are typically teaching and helping students to do?
Yeah. I mean, the biggest gap is people, right? Because you can learn all the maths in the world and all the theory in the world, but when you go into the engineering world, the thing that hits you in the face is that very rarely is it a technical problem. I mean, I've made probably close to 1,000 products, and I don't remember many of the technical problems. Like, usually it's something, how do we fix this? And by the end of the day, you've found a solution. The problems that persist and the problems you come up the most are people and organization problems. You know, somebody wants this, somebody else wants that. We had a spec that we were designing to, and somebody's changed it. We want to buy something new, but procurement can't handle something that isn't in the usual format. These are the problems that education just doesn't touch on. Like, it's really hard to learn theory without application. And schools are getting much better at application, starting to talk about projects specifically, because, you know, my biggest win in my career has always been that I've always had something to search. You know, I design a lot of race cars now. Race cars are my thing at weekends, and people will message me on Instagram and will say, "Hey, can you teach me how to design a race car?" I'm like, no, it's a massive problem. But if you want to know how to design this brake caliper bolt to take the amount of force that you need and how to calculate the force so you can design the bolt, I can teach you that. And schools are getting much better at teaching in that way, where you've got very specific problems that you can then extrapolate out and you can apply to different things and understand theory rather than just memorize it. But still, there's this huge gap between learning how to design something and learning how to work in engineering, which is all people.
Right. And so what do you think of those gaps? Like, when you talk about people, how do we help engineers really connect? Like, it's not just the analysis, it's not just the technical issues and the things we need to learn. How do we help them come along to the people issues that they need to learn and gain those skills?
I think a lot of it is genuine experience. Like, you can't teach somebody how to deal with the politics that seeps into the engineering department. Like, the work experience is great. Anytime you can go and spend in a business, even if that's a couple of weeks and it's, you know, it's an unpaid internship or it's work experience, whatever it is, that will bring you so much value to your career that you can't really quantify, because you're getting exposed to the actual problems, the actual frustrations, and the things that actually hold up a lot of the engineering. I think the more you can bring like simulated client relationships into engineering teaching, because, you know, there's a lot of people that will say, well, you know, a lot of engineering isn't client and customer based. A lot of it is internal, and you know, look at Lockheed or one of these big engineering firms. We don't have clients necessarily. We're designing something ourselves. But you still have clients, you have stakeholders, you have people that want something on a Tuesday, and by Wednesday they've changed their mind, and, you know, you go around in circles. I don't think school prepares you for that frustration. It prepares you for the frustration that you realize that suddenly we've got friction in our model, but it doesn't prepare you for the frustration suddenly you've got procurement in your model. And I think the more exposure we can have with that, the more we can simulate that. And I think that comes a lot from getting more people who are in industry or just recently out of industry to come and teach. Because that's the best teachers I've had, were people who've done the job and come in and gone, we're going to learn this today, but it's going to take us 10 minutes, and then I'm going to teach you about how it actually works when we go and apply it, and how painful and frustrating that is. But that's how it is.
Yeah. So maybe, Josh, it would be fun to have you illustrate one of these experiences that you've had where that really highlights a big technical or people challenge that you had, or something you were trying to create that really said, hey, this is maybe how education would teach you how to deal with this, but this is what the real world taught me. Any examples that come to mind?
Yeah. I mean, so I didn't go down the university route, but I did the whole applying and the interviews and everything else. And the moment where I said, I'm not going to do this, I'm going to go and play myself, was I was in an interview for a university, and they set, you know, one of these questions, and they said, here's this design for this new turbine fan for generating electricity. What's wrong with this new design? And I looked at it and I said, well, the problem with this new design is it's new, it's procurement. No one's going to want to buy this because nobody's validated it before. Therefore, we're not going to be able to build enough of them because nobody's going to buy them until something else has proven them. Your biggest issue with this design is building the CapEx to prove the point before you can launch it. And we ended up in this 2-hour-long conversation about how, no, it's because of this parabolic curve and this is going to create turbulence in the wind generation. It's irrelevant. If it's more efficient than what you had before, that's great, but it's irrelevant because it's new and no one's going to buy it. And if no one's going to buy it until you've proven it, you need to buy it and you need to invest in the R&D to prove this point. So whilst your R&D spending maybe tens of millions, you've then got another X tens of millions to go and prove this stuff out and be able to sell it. So your biggest issue here is not a parabolic curve. It's actually the fact that this thing is new. And that really highlighted to me, this gap between education and engineering, which is very theoretical and it's really important. But then what actually happens, and a lot of the cases where people haven't had that exposure to these kind of pains, where I'd spent the last few years working with these kind of people who go, I want this, but I want to see 10 other people use it first, but I want to be the first one to use it. And you're like, hey, these are impossible problems, but that's real engineering. So yeah, we see that a lot. And I think the more exposure to that you can get, the easier it is to handle them. I get a lot of fresh-faced engineers who are absolutely brilliant, but they see this for the first time and they can't believe it. They think they've gone back to school.
Yeah. Well, it's interesting. You think about that theoretical knowledge that you learn in school, and that, yes, we want to optimize designs and make them as efficient and cost effective and everything as possible. But when you're talking about how do we actually get that in use, if this is an improvement, there's a whole lot of other things other than just the design that need to make that happen. And that's often what is neglected in the engineering experience, unless we're turning that, or the educational experience, unless we're turning that into projects where you really need to get that adapted. So when you think about, okay, an engineer or a student finishes school, they go into the quote unquote real world and starts actually building things for a company, or maybe they have an entrepreneurial idea or whatever. How do they continue to take the things that they've learned, but also grow from there to stay relevant in the industry? Because things continue to change. Obviously, technology is changing, supply chains are changing, everything in between. How do they stay relevant as they continue forward?
I think, the obvious way is to ask questions, right? I think it's very easy to fall into the hole of just doing what you know, what you're good at, and being good at it, and proving that you're so good at this thing, whilst ignoring stuff that could be new because it feels challenging or it feels like you're not performing as highly as you could be. I think you have to let that go. I think the best engineers know to ask questions, to say they can't do things, to look for help and support across a business or across mentors and peers. I think the other thing is to have projects. I think it's quite rare nowadays to try people with hobbies. I think engineering is one of the last kind of industries where people have a hobby and they do something at the weekends, or they do something in their evenings, so they're making something, and it's not your career, but it's a big part of how you learn what you're doing. I look at my team and the people we've hired over the years, they're always people that have got projects. First it was robotics, and it's people that work in cars, or people who have projects designing their own, which have been designing their own sports equipment, designing their own products to launch on Kickstarter. But they've got something where they're kind of doing engineering, but they're enjoying it. They're making something. And that's where people learn more, because the reality is that most engineering jobs, you get given a project, you concentrate on it for 6 months. It's usually quite niche, and you're learning very specific things around it. If you want to keep that knowledge broad and you want to learn as much and as quickly as possible, then you need to take responsibility for bigger projects. And usually the only way to do that is to have a hobby. You go and don't have to design a car, but you might say, okay, I'm going to enter the Red Bull soapbox race, or I'm going to build a go-kart, or I'm going to go and do this over here. I've got this barbecue in my garden and I want to have some new table for it. I'm going to work out how to design and manufacture that myself, and all that kind of stuff. It feels maybe not like professional engineering because you're not sat in a room with a whiteboard, but that is where you learn the real skills to make stuff. And if you can understand how to make it, you can understand how to design it.
Yeah, at least get some tools and maybe a 3D printer and look around for problems they need to solve to make things better around the house or the apartment or whatever, and say, hey, how could I create something that would be better than, or at least different than, a lot of times we can buy something cheap on Amazon or whatever, but you're going to learn a lot more if you go through the process to exactly. Which maybe isn't always the most cost effective, but the learning experience is worth it for sure. Now, Josh, you were talking about when you were talking about asking questions and being really curious, you're talking about mentors and teachers in that way. So talk to me about how you view the role of mentors in your life and how important that is for engineers who are continuing to grow in their careers.
That's huge, right? If you get the opportunity to take on some mentors or to be a mentor, it's huge in the industry. I don't think I realized until a few years in that the people that were supporting me were mentors to me, right? They were just telling me stories about things they'd done in the past, just answering my questions. But you learn so much from that real world experience. You'll learn 300 times more in a 10-minute conversation about what happened to somebody in this one time than you will reading 10 books. Because they're real, they're relevant. You're able to have a conversation, you're able to understand the nuance, and it's much easier, certainly for me, to remember somebody's story than it is to remember 10 pages of theory. So I think trying to collect those kind of people, not putting a huge pressure on somebody, I want you to build me a syllabus and teach me everything, but just having people to call on that have been in this field, been in adjacent fields where you can go, look, I'm struggling with this, what do you think about it? Or this is what I did this week. And it doesn't have to be, I've got a problem, can you give me an answer? Sometimes it's just telling them about what you've done and hearing the anecdotes that come from that. And there's a huge number of people in the engineering field that, maybe they're in the peak of their career, maybe they're coming towards retirement, and actually they really enjoy being able to give that back and also understand where the younger workforce are coming from. I find a lot of more experienced engineers, they don't know how you get taught engineering anymore. So their opportunity to mentor is also for them to know, well, what is it these younger engineers know? What is it they're focusing on at school? What is it they're focusing on when they come into the business? And therefore, what can I add, or how do I understand better how to work with them? And I guess we're a few years after the shift from people drawing on paper to working in CAD, but you'd be surprised how big that gap is still between the younger engineers who have got a real grasp on technology and automation and the older engineers that had to do all this stuff by hand. I bet you they can tell you how that automation works a lot better than you understand it. And sometimes it doesn't hurt to learn some of the old school stuff to be able to do this better. Yeah,
totally. And so in your mind, are there different kind of categories or types of mentors that you find are useful depending on what you're trying to figure out or how you're trying to grow?
Yeah, I see two categories of engineers, right? You've got your real technical engineer that doesn't want to manage people, doesn't want to deal with people. They want to design interesting stuff. And they're a brilliant mentor because they'll teach you the real technical stuff and they'll teach you how to deal with frustrating political scenarios in business. They're not there trying to work the room and everything else. They'll teach you how to deal with it when Bob walks in and tells you that everything you've done isn't what they wanted, but it is what they wanted, and that was what was written on the spec, and they change. They'll teach you those stories about how to deal with this stuff. And then you've got the other side of the engineers who are the managers. These are the people that can really work the business, work the client, work the room, and they'll teach you how to go from the other side and actually control those situations, create the situations you need for yourself, but still with a technical input. I think if you can find one or two people in each side of that account, you get a real good view of what's going on in the world. The amount of experience they've got isn't critical either. You don't need to find somebody who's 50 years experience. Sometimes finding somebody that's a few years older than you, that's just had a few more years foot in the door, is really valuable because you'll hear very recent experience of how they've moved up the chain, what they wish they'd done differently. And ask these questions. People love to share how their world works and love to feel like they're giving back. It's a real value. But be respectful about how much time you want from them and how much you're asking. Having a chat with somebody is always a lot easier than asking them to teach you something, because it's very hard to be taught engineering as a broad subject. You need specifics.
Yeah, absolutely. And I'll add one differentiation or separation that I find to be useful. We're talking to a lot of people who might be inside of engineering companies doing engineering work, and that's great. Or maybe they're still students or whatever. Finding those mentors who are where you're at, bosses or other engineers who are maybe more senior to you that you can learn things from. But it's also important and helpful to have mentors and coaches and others who are outside of your current organization, because they see things that are different from how your organization, your team is doing things, and they don't care about whether or not you stay or go. And in terms of growing your career, they don't have any buy-in as far as that goes. But you want to get those different perspectives from people outside of your current organization to see, hey, what else is going on in the industry? How are other people solving these sorts of problems that might be different than the way that we are? And you get those different perspectives when you do that. So that's just another differentiation I found is helpful as well.
Yeah.
So, Josh, I'm curious, you've been in the industry, you've made, like you said, like thousands of products and things. Are there trends and changes that you're seeing that engineers need to be aware of and paying attention to as they continue to grow from here?
Yeah, I think it's longevity. I think when I started my career, you design a product, you launch a product, and that product runs for 10, 15 years in market and everybody loves it forever. Then it sort of shifted to like, okay, maybe every 3 or 4 years we'll launch a new version because technology is moving along, we'll update things and we'll move on from that. Nowadays, it's like 12 months is a long time in market. Like people are designing products knowing full well these things are going to be like sunset within 12 months. Because technology moves so fast, but also we've kind of built that environment in the market. Like consumers don't want to buy the same thing that was available a year ago. So the whole world of engineering has changed from how do you build something that really lasts and has strength to actually for a lot of products, how do you build something that can go to market, work as efficiently as possible for 12 months and then be recycled and be handled in the right way to be able to be upgraded, disposed of, recycled into which were all constituent parts. That's a huge shift. And I know there's still industrial engineering that does last for 20, 50 years, but if you're looking at consumer engineering, that's a massive change from where we were 10, 15 years ago. And I think, well, I know that the syllabus hasn't caught up to that world. So as you're coming through to the end of your engineering education, keeping that in mind that the world has changed. We're not designing things for long term anymore. We're designing for rapid innovation, rapid change, rapid deployment, and then rapid sunset products. Everything's moving incredibly quickly. And the best thing you can do in that environment is not just learn how to design that thing, but it's how to design systems so you can build things in that category. The way you're investing your time isn't in a product that's going to get sunset in 12 months' time. You're investing your time in how to build a system to design those kind of products. I think when I look at engineers moving across businesses and we're considering that they're going to work with us, etc., I'm looking for engineers to build their own systems and processes for how to do things, as opposed to invested all of their time and energy and knowledge into a single product that we know isn't going to be here in a couple of years' time.
Right.
So I think that's quite important to keep in mind, right?
Yeah. So we're thinking about not just what you're building, but how you're building it and how you can replicate that process to do it again and again and again and keep improving things on the system side, not just the single point of focus there. Oh, great thoughts there, Josh. And this has been a fun conversation thus far. Yeah, go ahead.
No, I was just going to say, I mean, I get people that come to us and one of the things they bring out is not a portfolio of products they've designed, but it's like all of their CAD shortcuts they've designed, their macros for SolidWorks and stuff like that. And we're like, yeah, okay, what you've designed is not a product. What you've designed is the way you could design products quicker and bring us new systems and automations and formulas and that kind of stuff is becoming a real valuable commodity. And it's worth considering when you're thinking about who you are as an engineer.
Right. And how you optimize the time that you're spending to get the most value out of that time and create the most innovation you can in the time and the effort that you're spending, utilizing all the tools you have around you and using those tools to do even more work and create more impact. It's awesome. So, Josh, what a fun conversation. You've expanded my mind in a number of areas, and I know it's been helpful for our listeners. At this point, we're going to go over to our Take Action Today segment. When we come back, we'll get one final piece of actionable advice from Josh. We'll be right back. Now it's time for our Take Action Today segment of the show. Now, Josh, we've talked about a lot of different things about how do we expand beyond just what engineering education is teaching us to be successful in careers and other ways we can lean on mentors and things. As we end off here, what's the final piece of advice that you would give to engineers early or established in their careers to continue to grow and develop to become the best engineers they can be?
Yeah, I think we come back to what we said earlier, having projects, like having a passion for engineering, having an ability to effectively take it home with you, but without working all the time, right? Being able to design stuff for yourself, finding those projects, whether it's designing furniture or it's working on your car or it's working on something for the home or just having something where you're making things, you're designing things. It's kind of like passive learning, right? You're learning all these new skills about making and designing and the maths behind it. And you're thinking about the mechanics, whether you're still at school or you're 20 years into your career. The more hobbies you have, the more you're going to learn. And I think engineering's so overarching of everything you do that you've got hobbies, you're advancing your engineering.
Yeah, great. So have those hobbies and those things you spend your extra time on be related to things that you want to be learning and growing in your engineering career, and that's going to help you out as you continue forward. So Josh, such a fun conversation. As we end off here, I'm sure there's people who might be interested in connecting with you learning more from you and in other ways, where would you point them to learn more?
Yeah, for sure. Come and find me either on LinkedIn as Josh Valman, or you can find my website, joshvalman.co.uk, or my company, if you're interested in looking at engineering careers in the UK, www.rpdk.co.uk.
Okay, perfect. Thanks so much for being here. And we wish you continued success as you continue to influence the engineering world in the way that you are. Thanks so much.
Awesome. Thanks, Jeff.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and questions. You can go to engineeringmanagementinstitute.org, where you'll find a summary of the key points discussed in the episode, as well as links to any of the resources or websites that we mentioned in the episode. And don't forget to check out any upcoming live webinars for this month at the website as well. Additionally, for any engineers who feel like they need extra help taking the next career step or finding clarity in their careers, I've created some free training resources with an opportunity to join a more intensive program called the Engineering Career Accelerator. You can find more information at engineeringcareeraccelerator.com, or you can go grab my Career Clarity Checklist found at www.engineeringcareeraccelerator.com/career-clarity. Until next time, I wish you the best in all of your engineering endeavors.